Think about the phone in your pocket. To build it, materials flow across oceans, pass through multiple factories, and involve thousands of workers across dozens of borders. How does a company actually keep track of the billions of dollars funding that global assembly line, ensuring value doesn't simply vanish along the way? To answer that, we have to look at humanity's earliest solution for tracking assets. Thousands of years ago in Mesopotamia, record-keeping was driven by governments trying to manage agricultural surpluses and collect taxes. They used a single-entry accounting system. This was a basic linear list. You add 5 bushels of wheat, you write down +5. You sell 3, you write -3. A list like that works perfectly well when your entire economy operates within a few square miles. The variables are low enough that human memory can bridge the gaps in the data. But that localized approach collapsed in Europe during the 13th century. Commerce expanded outward, connecting disparate cities into complex, multinational ventures. Suddenly, merchants were dealing with simultaneous shipments across dangerous seas, managing inventory sitting in foreign ports, and taking out bank loans to finance it all. This scale revealed the fatal structural flaw of the single-entry list. It has zero built-in error detection. A single unrecorded loss or a slip of the pen goes completely unnoticed. Because the list is linear, that one mistake creates a compounding chain reaction. Every subsequent calculation is corrupted, meaning your final balance has no connection to the actual cash in your vault. If you can't trust your own internal data, you can't take on the risk of a new loan or a new shipment. Global trade hit a hard mathematical ceiling. By the time of the Italian Renaissance, Venetian merchants had figured out a localized, proprietary bookkeeping workaround to handle this complexity, keeping it a closely guarded secret. Then comes Luca Pacioli. He was a Franciscan friar, a brilliant mathematician, and a close collaborator of Leonardo da Vinci. Pacioli studied those secret merchant ledgers and saw the need for a standardized protocol. In 1494, he published a sprawling mathematical text called the Summa. Buried within it was the first published codification of the double-entry accounting system. Pacioli laid down a rigid mandate. Every single financial event has to be recorded twice, once as a debit and once as a credit. This rule enforces a specific framework known as the accounting equation. Total assets must equal liabilities plus owner's equity. Take out a loan, your cash increases, but liability increases equally. The books remain perpetually balanced. Pacioli had engineered a self-checking mathematical proof. If the sides didn't balance, you knew instantly there was a mistake, structurally eliminating the silent errors that plagued medieval trade. Publishing the Summa effectively open-sourced this methodology. Anyone across Europe could now learn to speak this exact same mathematical language. Because this double-entry system guaranteed internal accuracy, businesses could definitively prove their financial health to outsiders. If the books balanced, investors and banks could trust the numbers enough to provide massive infusions of private capital. That newfound ability to safely aggregate capital allowed companies to finance infrastructure projects, laying the railroads and building the massive factories of the Industrial Revolution. As corporations grew larger and more complex over the next century, the demand for verifiable data led to the creation of the SEC. The government legally required publicly traded companies to report their finances using this strict, standardized framework. We've moved from clay tablets to AI algorithms processing millions of trades a second. Yet, the structural backbone running modern Wall Street is still Pacioli's 500-year-old equation. This self-verifying architecture of accountability provides the foundation that allows humanity to confidently build and scale the future.